to be access the workshop. But anyway, I welcome you all for this workshop, a Homer Pro workshop. So the workshop will be conducted by Arvind, very soon to be Dr. Arvind. Okay. So we really appreciate because you accept my invitation and being the resource person for this workshop today. Yesterday, I just gave very small introduction on the home energy, this website. So can you please, Arvind, go to support? Because I'm not going to share my screen since you have shared already.
Okay.
So here, because yesterday I just introduced this video library, and then I got one question about recommended videos. Can you please go to the video library?
Okay.
Yeah, here. So please go to the videos. No. So Arvind,
Which
please
video?
go back. Yeah. Yeah, videos. Yeah, please go down. Yeah, here you can see, because one student requested recommended videos from this library. Here you can see the very beginning videos. They are very short clips, short duration clips, just only 2 minutes, 3 minutes, and like that. And I understood that it gives a very good introduction for this software and features. So today you will be getting very good insight with Arvind about Homer Pro software, and I recommend you to start with these small video clips. So it gives you again the basics, and then based on your requirements and your interest, you can select long duration clips. Here you can, if you go to this long duration clips, you can see it focus on some specific topic. So it's something like that. If you are interested in selecting a topic with time series analysis, so we can recommend these videos for you after Aravind workshop. Okay. So as I told you, in this course, when you are selecting your topic, that means some problem statement related with smart grid issue, to give some solution for smart grid related issues, we can perform basically two types of analysis: time series analysis and snapshot analysis. I told you for steady state cases, we are interested in time series analysis, and for dynamic cases, we are interested in snapshot analysis. So Aravind is going to conduct, I think, 3 workshops with Homer Pro and Homer Grid when the course is being progressed. All these 3 workshops going to be related with time series analysis. And also I'm going to conduct several workshops, out of which some will be focusing on time series analysis and some will be focusing on snapshot analysis. I think that's the only thing from me. I request Aravind to record this workshop from your end. I made you the co-host. I think you have that facility because
record.
Yeah, because at the initial lectures we got request from the students.
Okay, but I never did it before. How to do it? Is it?
You can go to option.
Okay. Stop.
And there is a record.
Just. Okay. Recording this meeting.
Yeah. So I'm also recording from this side, and you also can record from your side.
Mhm.
Okay.
Okay.
Okay. Thank you, Arvind.
Okay. Thank you, Konara, for introducing me, and I welcome all students to participate in the Homer workshop today. So, as Konara already mentioned that he has shared some documents with you and these videos and links of these videos. So, I think I will not take much time, and I will just start from a very beginning of the video, like very beginning of the software, where you can understand that how this software works and how what are the features associated with with this software. And this is something Konara has already explained you that this Homer Pro is available here in the download section, and we can download this software for 30 days. I think 21 days. 21 days. It is available. Free version is available. So here I'm going to cover this Homer Pro software, but in Homer Pro we also have Homer Grid, but that is not going to cover here. Mm, Just so I'm just playing one video that will give you an insight about the software. So this is the video.
I'm sorry to disturb you, Arvind.
Yeah. Yes.
So before just going to the software, can you kindly please give some overview introduction about this Homer software? That means what type of analysis? Okay, as overall, I'm asking what type of analysis that can be performed using this Homer software.
Yeah. Okay. Konada, I was playing this video. If voice is not, can you? This voice was available. Would you able to listen the voice of the software while this video
No.
was? No.
No.
There is some problem. Maybe because my voice is on.
Yes.
Now it was available. No.
No.
Okay. Don't know. I thought this is something that you have covered yesterday, that you have shown how to download the software, but what are the features of this software. So anyway, I'm just explaining the few features of this software. This is very advanced software for microgrid development. Not only the microgrid, but like off-grid solar PV projects, renewable energy project, and grid connected projects, and to design the optimal sizing of the system, battery energy storage, and the different component of the system based on the requirement of the load and based on the different geographical location. The software has very advanced features in terms of we can select here different types of loads within the software. If you can see here, we have like we can define our loads within the software. So if you want to analyze for a microgrid system for a community, then the load pattern can be different for the industry, for the commercial buildings. So we can analyze a different kind of load patterns. Secondly, we can also see here if we are going to take what kind of resources we want. So we have option here to integrate from DG. Is it? Would you able to see now this screen of Homer Pro? Yes, good. No, Homer is here. Yeah, thank you. So here you can see in the software we have different kind of renewable energy sources, and like here we have the controller, we have generator, we have solar photovoltaic modules, we have wind turbine, battery energy storage, we have converter if you want to connect between the energy resources and with our load, and the custom tools. We have boiler if you are going to use heating systems for heating load. Then we have also hydro, reformers, electrolyzers, hydrogen tank, hydrokinetic, and of course is grid and thermal load controller. So we can design like vast different kind of energy systems, and we can make a techno-economic sizing as well as long-term predictions in terms of how our system is going to behave shortly and in the long terms. So Homer has a capability to analyze the scenario. Like we can analyze here, like how our system is performing at a different time interval. If I want to see how our PV solar photovoltaic is generating the energy, so we can see in the next 1 hour or maybe in the summer season or in the winter season how the solar PV generation will be there. What would be the contribution from different energy sources, for example from PV, from battery, from DC generator, or whatever energy source I'm going to connect. So we can see which kind of energy source is available that time and providing electricity energy to the load. Simultaneously, we have also advanced feature here, so we can the Homer will give us the best option in terms of minimum energy cost generation and minimum overall net per gen cost. The Homer will give us the best option available based on the different optimization techniques. So once I will take you to the different results pattern. Once we will complete one simulation, then we will analyze the results. In that, we can see how the different kind of results we can interpret it, and also how we can use those results for our analysis purpose. So this is like a small background that I have shared with you, what is the capability of this software. Besides this software is basically for microgrid, and as I mentioned, microgrid and grid connected or grid systems. But we have one another version of the software called Homer Grid that is more more into the economic assessment based on the electricity tariffs. In that software, about that software, I will discuss in a separate Homer Grid workshop. And in this software also, we have capability to analyze the grid performance based on the different energy tariff, but with some limited capability. So that is also one good features of this software. So now I will take you toward the tour of this project. I will share this screen, my YouTube screen now, and we'll see if you are able to listen the voice. Okay, I think this voice is not, you are not able to listen the voice. I have sent a link, but I will explain this what overall the video is they are going to explain. I will explain you through this Homer Pro software. So I am sharing one another screen with you. Now, would you be able to see my Homer software screen? Everyone able to see my Homer screen? Yes. So now, whatever that online video they were going to explain, I will explain you here. So here also we have capability to see. If we go here in the take a tour. So this is about the software, and like in the Homer Pro, it is an industry standard rapid assessment of least cost solution. So as I mentioned that the whatever calculation we will calculate here, we will do the system sizing that will be based on the minimum energy generation cost of the complete system. So, like the get initial results with the Homer optimizer, review simulation optimization and sensitivity analysis, define the optimization using Homer search space. So, in this software, we also have a capability to fix our size. Let us take an example. If I want to fix the size of my battery, so we can define the capacity of the battery in a particular system, and then we can analyze the results. Instead of asking to the Homer software that the software will give us this value, we can put our own value and we can analyze the results. So I will move in the next slide. So here, this is something that I have already explained you, that different kind of energy component and like distributed energy generator is available here. While making any kind of systems, we need these selected systems which are shown over here. So we can select that, and then how we configure these systems, that I will explain you later. So now how we begin a program. So in order to begin a program, we begin with the setup assistance of project information. So the first thing is that we need to put this like the project, and then we need to put the location. What is our location? So here location is very much essential, because whatever energy source we are going to take, like if we are going to solar, wind, and for that specifically we need what are the geographical location and what are the climatic condition over there. Solar radiation for an example, temperature, and wind speed. So all these parameters we need to have this data. So in this software, this data is available from the National Renewable Energy Laboratory (NREL) and also from NASA. So once we select the location, we can download the resource option here. There is a resource option here. So we can download the resource available here. So we will get the relevant resource data for our project. So next thing is that we need to specify our loads, what kind of load we are going to select. So here in the Homer Pro, the good capability is that we can define different types of load. So like for an example, there are some by default load features are available here. So if you can see here, this is residential load. So this is a kind of pattern. This is available here, and we can scale up this load as per our requirement. So like 4 category of load are already available here, like commercial, community, industrial. Beside this, if we have our own load pattern, so we can fix that load in a CSV file, and we can feed into it, and we can generate our own profile. That is also the possibility. So now next is the grid. So in the grid, while defining the grid, grid has like very advanced feature, but in this window you can see there's very limited features have been shown here. The first, you can see like the grid price. We have just considered the grid price here, but once if we are going to analyze the advanced features of the grid, then several things will be come into the picture. For an example, the grid rate. Beside the grid rate, we need the peak power rate, like peak hour rates, and also how our grid price, energy price are varying throughout the year. So if you can that data also, so we can generate our own tariff. But here we can see like for an example here, I sell electricity with a feed-in tariff. So with the feed-in tariff price, we can sell the electricity. We can select this option. We can also see I cannot sell electricity back to the grid. This option we can choose if we don't want to feed our electricity to the grid. For an example, we have a solar PV, and we want that most of the energy should be used by our local energy system or local loads available. So we will not feed that energy into the grid. So we can take this option. So we will not sell any electricity to the grid. So we will not get any credit for that. So it will not get any value in our economic assessment. So if we'll move forward, then we can see the generator here. So in generator also we can define the capacity, or also we can ask Homer, if you have a load file, that what capacity of generator is required in order to meet the demand. And in this generator, we see the fuel cost. We need to fix the fuel cost here, and then we can define our variables. Then of course, this is the renewable energy, like for an example, solar and wind over here. And we can define this the cost of the PV. Like for an example, you can see the cost of PV dollar per kilowatt here. So if you have value of this solar PV in terms of NOK, we can choose the NOK as well. So all things, the system will consider all things in the NOK. So we have option here to, in the dollar, whatever currency we want to choose, it will convert the currency accordingly. Secondly, like if we have a big power plant, like megawatt scale power plant, and we want to size different kind of systems from 100 kilowatts to 1000 kilowatt and like megawatt scale. So in that case, we can also put PV price range from like, for if it is in this range, then the price would be like this. If it is higher range, then price may be a little bit lower. If you are moving more into the megawatt size, then price would be like little bit more lower. So we can define these features into the system. Similarly, in the wind turbine, so but both of these kind of systems, we need the resource. So initially, when we will start our project, we will required the resource. So as I explained, as I explained you in the beginning, that while generating any project, we need a resource for this, making the project successful. So now we can select the storage. Within the storage, we have several kind of option available. We can select what kind of battery we are going to use, lead acid battery, and within the lead acid battery, like different voltage and capacity, what our capacity combination we can choose. Within the battery technology, we can choose lead acid battery, lithium ion battery, and we can select their cost as well, how the cost is going to vary. Then after putting all this information, we can put this information, basic information project, what are the discounted rate, and then average load profile. This is something that the system automatically calculate when we put these values. And yeah, and this is something after that we can run the program, and the software will let us know if anything is missing within the our design, and if anything missing, then the Homer will automatically convey us that you need to add this equipment, or this generator, or like converter. You need resources, and what is missing over there, that we can choose. So up to this, I just give you an overview of the features of this Homer Pro, and how it is going to use to develop a model for microgrid. So here, as you have already got one document, like I think the article, there is one article which is based on Homer Pro, and I have already shared, I think Konara shared with you guys. That is for the article is from Journal of Greener Production, and the whatever input parameters I have taken there, I will take that as an example here, and I will try to show you how we have developed that system and made the analysis. But that will be good understanding for you. So for an example, I will open that article also for you. Maybe you can just have a look. If you don't have copy, you can let me know. I can
Excuse me, Arvind.
yes.
Actually, we shared our SETA journal.
Okay, no problem. I will. Can you put this clean energy production also?
Yeah, sure. I will do it.
No
So
problem.
please, after this one, please little bit discuss on the SETA journal as well. Okay, Arvind?
Yeah.
Okay. Thank you.
Actually, both articles are almost like analysis wise. This is more about the tariff. I can also, but thing is that in this I want to show you the same kind of data but I have taken, but I can yeah, no problem. So I will just give you an example. This is the developed model. Can you see my screen? Right now I have like this essential load, non-essential load here, DG. Can you see this in my screen? I think no. I will close this. So here, you can see show you one screen here, and this is Homer Pro. This is the program, like the developed program. Can you see this program? Like, can you see the DG here? Essential load, non-essential load, grid. I want to show this screen to all of you. So here, initially, we have a system here. This is something that the system is developed in the Indian climatic condition, and you see it is like the data is used here for location like near Delhi region. So I will take a fresh program for this Homer Pro. I will take that as a base. So you can see this screen. Welcome to Homer. When you open a new program in the Homer, you will see this window. So here I have already explained you about the setup assistant, then the take a tour, and the continue to the Homer for the program. But now we will make a program in the Homer. So now, as I mentioned, in order to develop a program, first we need to mention the name of the project. Suppose this is microgrid. Here microgrid, like India. But yeah, and I need to first fix this location here. Where is the location? So we can search here also, like we can, if we put here, so it will identify this location. And once we'll go to the resource, we can download this data for solar, because we are using solar here. So you will get a message here. Can you see this message? That resource was downloaded successfully. Yeah. So once we get this message, it means the location that we have selected in our software, the resources are available over there. Okay. So now we need to fix this parameter like discounted rate, inflation rate, and then annual capacity shortage, project lifetime. I am taking this value from the project which I have previously developed, and this value, if I see, is 6.25. I will not take much time here. This is in the Indian context. I am just putting here 6.25. Then inflation rate. Then 4.75. Then project lifetime is 25 years. I have put this value over here. Now what is next? Next is we need to have this component in the software. So what component we need here? we are going to first analyze the system in the India context. We have a load, essential load and non-essential load. And for that load, if you gone through the paper, then in the paper the system is like this. We have a. I will take you to the. So we have like. So I am sharing one another screen now, and this screen is screen out the paper screen, the paper that I am discussing with you. So this is on techno-economic evaluation of PV-based institutional solar microgrid under energy pricing dynamics. So as I explained you, would you able to see this load profile here, the total load and the essential load profile, and how this is going to vary? So I have used this load. Would everyone able to see this paper now? Good. So now you see the load profile here, essential load and the total load, and how this load is going to vary. It's like weekly profile of the load. And if you see this graph, this is the month of the year, how our how our load profile is going to be is varied in different month of the year. So first thing is that I am just designing a system for this load, PV essential load and the total load, and then it is going to be the load demand is going to be fed by the DG, because in India we don't have the electricity like in terms of reliability, we don't have a reliable electricity, so there is grid outage. Grid outage is there, grid outage. So in this scenario, we have considered 2 hours of grid outage randomly throughout the year. So when grid is not available, then we should have some alternative option to meet the load demand. So DG has taken here. So here you can see this is the DG profile. So when grid is not available, then DG will take care of the load. So in the first scenario, what we did, we have created this simulation and fixed this DG capacity and see how our DG is going to fulfill the load demand when grid is not available. Okay, and this is the table. You can see how this energy persists throughout the year and the peak load demand and the energy charges. Total electricity energy charges, monthly electricity energy charges. After that, once this is done, then you can see here. The first, what I will do here, I will in this blank Homer program, I will introduce this. I will take these components. Okay. I will make a program, normal program here. I will make one program here, but in another program, I think I will show you with the help of tablet program, and then it will be easy. It will not take much time to. But the first program I will develop with you. So I am again sharing the another screen, which is Homer screen, where I was working on this. So first is the load profile. So this is our electrical load. I have choose the load from here. So it gives us the homework giving us option here, like we can choose the available load which profile is available here, or we can choose a load profile which is like our own profile. So I have taken here like our own profile. So we have load profile. So like you can see here how I have taken this load. I have a file, CSV file available, and I just downloaded that file, uploaded that file here, and we can see the electricity load here. Then I'm also choosing another electricity load, like this was essential one, now second one. So I have taken two load here. Okay. So I need to see which is. So this one is like essential, the program essential load, and this one is non-essential load. Okay, so now you can see if we don't know what to do, so Homer is asking us to add a power source here. So it means we need some power source. So as I mentioned you initially, we have considered a system where we have the grid and DG. DG is using to meet the load demand when grid is not available. Okay, so I need to first fix a grid here. So in the component, I will add grid here. So grid is connected, but in the grid we need to fix the price. What are the grid price? So like I have taken here 8.35. So like I will fix here the price, but have been taken 8.5, 4.5. So here you can see the grid electricity price, buying price I have taken here 4.5, and the selling price is like in the buying price 8.5 and selling price is 4.5. This is something that I have taken. Okay, then move. Then here also fix some demand rates. So in according to there, the demand rate is like 160, and then go to the reliability parameter. Is the reliability. So as I mentioned, like in the case of India, and the grid is not reliable, so I have considered like 2 hours of random grid outage. So this is something the software automatically defined this grid outage scenario. And if I move here, so I have taken here like 365 days, 2 hours of grid outage. Repairing time, I mean, if you put repairing time, so it will add 2 hours plus like whatever I will put here, 2 hours plus 2 hours, like 4 hours. But I am not putting any value here. The repairing time I'm not considering. I'm just saying that mean repairing time like 2 hours of grid outage will happen every day, and it will be distributed like throughout this year, randomly distributed. So according to the plan, accordingly you can see when I put this 2 hours, you can see this window here. This is the black spots. This black here is showing the grid outage point throughout the year. In the X scale, you can see this is number of days, 1 to 80, 1 to 360 days, and in the Y scale you can see this is 0 to 24 hours. So like our grid outage is happening every day, and you can see how this going to connect. So like if I put here like 4 hours, so you can see it is like this. If I put more, so it will calculate like this, like more black is going to happen. So but here I am putting like 2, so it is giving us this value. So thing is that this particular values will be changed whenever I put this value, so it will not be same. So like if I am going to compare a results of today what I have got based on the analysis, and tomorrow I am changing this value again, so the both results will may vary for the particular day or particular month. So now I think we have connected everything, but as I mentioned that grid is not reliable here. So in that case, what will happen when grid is not available? So we need some alternative source to feed to meet the electricity demand. Okay, so for that we have the DG generator here. So I have taken DG in our case. So you take DG. So I will show how to take DG. So you can see this is a generator. I'm taking the generator, and I'm taking like a small capacity of DG because in this program, the small capacity of DG is used. Okay, and we can change this parameter according to our demand. So here, in this case, 50 kg of DG, and then its price like this all currency are in the Indian currency. I'm putting the values. So you just it mentioned dollar, but all things are like in the Indian currency. So the results will be on the Indian currency as well. Means in the US dollar, but we will analyze the results as it is representing the Indian currency. And this is the value. Fuel. So like here we have like diesel. So I have put this price over here. And what are the other parameter? Load is 50. The performance of the system also varies based on the minimum load ratio. So minimum load ratio is like at what capacity, at what minimum capacity level DG will operate. So at least if I'm selecting here 50 kilowatt of DG, then it will always give a 25 kilowatt of power. So if you are not going to use that power, so it will be lost. Okay. So this is the existing system, like what was available there, and no, this is operating mentioned cost. This is 70 is the diesel cost. Here diesel cost, and this is the O&M cost, and this is the diesel price. So now I think connected all resources with a base model. Okay, now if everything is connected, then we can see the results. For that we need to run the program. So here in the right side, you can see the calculator. So this calculator is being used to calculate the scenario here. So if I press here this, you can see it is start calculating the different optimizing scenario here. Okay, and it will give us the results. So now you can see the software will give us like show us the best possible option based on the lowest NCP, net present cost, and COE, cost of electricity generation. So here the software is saying like the solution is available. Our electricity energy cost would be 12 rupees. It is like presented dollar, but here in Indian currency it is rupees. Okay, so I will just compare this. Yeah, in my previous actual model also the cost is I think almost same 12.15. That is 12.15. Actually, these results you can like these results you can vary, but what I want to show you how you can analyze the result here. So here I will tell you like this is a generator capacity, so 50 kilowatt. The system is saying like Homer is telling us that our DG capacity 50 kilowatt we have fixed here. Then grid we have like unlimited grid power available here, and it has taken a dispatch as strategy like CC like cycle charging, NCP net present cost, COE, and operational cost. Then initial cost is like this. Renewable energy fraction is 0. We don't have any renewable energy here. Then what is the fuel consumption over the year? And then hour of operation, how much our DG has been operated. This is DG. Its production cost, fuel consumption, O&M cost, grid. So here you can say that like grid sold is 0 because we don't have anything available here to sold. This is only operating when our grid is not available. So in order to analyze more into this analysis, what we'll go to the we will double click on this row here. Anywhere we can just click here, double click here, and this window will open here. So within this, can you see this the new window which is appeared here? Can everyone see this new window? There is a new window here. Yes. So in this window, you can see there are different kind of header over here. So first is cost summary. So in the cost summary, we can see cost type and the category. And within the cost type, we can see the graph and how this cost summary is presenting the different kind of energy sources that we have considered. So here we have considered one DG and one grid. So this graph is showing us that what are the DG contribution and what are the grid contribution in terms of economic values. We can also see this the same result in terms of annual performance. So I will just click here. So it is saying in terms of the annual. Annually our DG contribution in terms of economic values like this, and grid is like this. The grid has more contribution, and it is definitely because 80% like most of the time we are using grid because it's only the grid is not available only for 2 hours in a day. We can also see this result based on the category, and the category is like components and the cost type. And you see by component the same. And if I select the category in the by cost type, then cost type it say the capital cost, operating, replacement, salvage, and fuel cost. Okay, we can also analyze all these results. Now I will move to the next header here. And again, we have actually three components here: DG, grid, and one is a system. The Homer just automatically take the system here, like the system cost here. We have like we can means it calculate the system cost, the overall cost of this generator and the DG, and then it's the total cost of the system. So total cost of total capital cost, replacement cost, total O&M cost, then total fuel cost, salvage cost, and then this is the overall cost of the system. Now we'll move to the cash flow. So this is a cash flow because we have considered here 25 years of lifetime of the project, and then our system will tell us that how our cost component, the cost of different component is going to vary throughout the year, throughout the project lifetime. So here you can see uh, cost by type. This is cost by type. Like types parameters are our, these are the types parameter: replacement, fuel, salvage, operating capital. Sorry, but we have also component type, and the component type we have like two component. Then we can see the grid and the DG contribution in this grid like this. Okay, here you can see like in this particular 21 years, the cost of this grid DG has increased because we have replaced the DG in this maybe after 20 years the DG has replaced. That's why this cost has increased. You can also see these results in a tabular form. You see, this is a nominal table in terms of, and then we can also see the discounted way, all these results. Then we can compare the another in the header. We can also compare the economics of this overall different parameters. Okay, whatever we have taken. Then these are the electrical parameters. You can see the electrical parameter here. How much energy is generated per year by the DG and the grid purchase and the total. We can also see the consumption, AC primary load and deferred load and total load. But here, like we have not defined like we have not categorized the load, so it's simply AC primary load here. Then here we can also see the excess energy here. So as I mentioned that why this excess energy is here, it is because that the DG sometimes would be generating more energy which is not going to use, and this energy is almost 5% of the total energy generated in a year. So this is significant amount. So we'll also need to be take care about the system while developing any system or while doing sizing, that we should not over size a system or neither undersize a system. So we should be very take care of this particular parameter, that exceed electricity generation. The good thing is that here you see the unmet electricity load is zero. It means there is no time where we are not able to meet the electricity demand, local energy demand. So we are meeting this demand throughout the year. Even not a 1 year, even not a 1 hour within a day. There is no scenario, no condition available here. Then we'll go to the fuel summary. So how our DG is performing throughout the day, throughout the year, like different months. You can see like in the April month, the DG performance are higher compared to the other months of the year, and the September also. This is also something we can analyze. And next is the small size generator and its performance. How our DG is operating like different day of the year, and it is the same graph, but we have created through this grid outage scenario. So this is something that has been reflected here. and there are different parameters. You see hours of operation of DG, number of starts, means how many times DG has started for operating and to meet the load demand. Then capacitor factor. This is something, if you do not able to get any, not able to understand any parameter details here, then you can go to the help section here, because there are a lot of parameter here. You need to know some definition. So we have help section here, and if you go to the help, and we can just type here like we have DG. Sorry, horrible. So we can like, if you want to see how this reliability work, in this help section, you can see the definition of all parameters, and also how we can define this, what I have explained you, and then about the definition also. What are the random outage, and then what is the algorithm used behind this, and the schedule outage, what is the meaning of schedule outage. All these things you can get more details from here in the help section. So I'm just giving you the overview how you can see. Then this is also the same thing about the grid performance. In the grid also, we can see how our grid is performing each month of the year. Purchase from the grid, and there we have not sold any electricity to the grid, so it is zero. These are energy charge, and these are the demand charge. Okay, and then we see this graph of grid purchase, and grid sold at zero. So once we'll connect any PV, maybe there will be some value here. And this is about the emission. What emission we are going to save from this. So where again? Yes. So up to this, is it clear to everyone, like how we have done this analysis? So if you understand up to this, I will just move little bit further. Now I will show this the time series plot, how it works. So now if I want to analyze the system performance based on the time series results and the time series, the graphical representation form, then we can go into this time series, in the time series section plot, and we can double click here, and we will see this window will open. Can you see this window, graphical window? You can there is some graph here, and you can see blue and like a little bit orange. It's giving us the plot of electricity demand, electricity load served. Can you see this profile? Okay, good. So I will just expanding it a little bit so that you can. So now you see in this particular time series graph, we can analyze how our system is behaving in terms of the contribution from energy sources and contribute and our load demand. So here you can see we have like total electricity load service selected here. Okay, and we have also selected the grid purchase, and we have also selected the grid DG, our small genset what we have selected. So I'm just removing this and removing this. So this is our electricity demand, total electrical load. So initially, if you recall that I have put two load demand. So in this particular graph, the load demand what was available there, they have the system has added both demand hourly and representing here the complete load demand. Okay, then I want to see these results in terms of like in the January months. I can expand this. I will just zoom it here. I can move it like this. So like this is the graph of January month of load profile. I can also see this load profile for a particular day. Like this is 7 days, and this is like for a day. If I go here, 12. So, so it means we can analyze the performance of the system hourly basis. Hourly result we can analyze here. Okay. So like this is monthly. So like if I want to see in the January month how much energy has come from the DG and how much energy come from the grid. So what I will do here, I will just see this is the grid purchase, the amount of energy taken from the grid, and I can change its color, maybe like red for grid. So I can see here. Now I can choose the different scale for the grid like this. If I select this, so this is our grid, and this is our load. But sometimes you see grid is zero. Sometimes grid is zero. But when grid is zero, then how we will meet the load demand? Load demand will be met by the DG. So DG I am just making it black and second form, and you see this is our DG. How our DG is operating here. So whenever this grid outage is happening, so our DG is going to operate. I can see it more closely if I take these parameters in the same scale here, and I want to like expand it like this. We can expand also like this. Just click here and like this. Click here and hold it for another pointer, and we'll expand it. You can expand it. You see, load. I will make it. So now, can you see in this graph? At this 10th January, 9 o'clock, we have some load demand here. Okay, and this load demand was meeting by grid. Grid is red. Grid is represented by the red color, and DG is represented by the black color. But what happens suddenly that after that this grid outage happened. Okay, so immediately DG start operating here. So you see, grid is getting down, and our DG is taking care of the load. And here for this particular time, our DG has met the load demand. This is something that we can analyze very closely. We can see very closely. So if I see for throughout the year how it is being performed, we can see like this. I have zoomed. So you see, this is a complete year profile. The black is our DG, red is our grid, and blue is our load. But you can see that we are not able to see the load because load has been covered by this grid. So what we can do, we can take this load in the different scale like here. So now DG and grid are like in the first axis, upper side, red is grid and black is DG, and the lower one is our load. Okay, and if we like expand this, we can see results. Do you have any question up to this? This is the basic concept of the software, how it works. But now the next question is that how you can save these results. And if you want to generate your own results, if you want to make your own graphs, is it possible? Yes, it is possible. You can take this data, you can save this data in the like hourly, in the hourly generated data of whatever parameters you have selected. All data you can select, and it you can save, and then you can generate your own graph, whatever graph you want. Okay. So here we can see other parameter also, like DG and DG capacity. Our grid price are same, not going to vary. We don't have renewable practice here. So now the next thing is that how we can save this plot. I am just closing that window, this time series one, but I am saving. I want to show you how we can save this graph. We can export the complete report, whatever we have discussed so far, from like this. There is an option in the left hand side, create proposal. So if I click here and I say create proposal, so I say like XYZ my group. Okay. We can create a project report. The system will create a report for us. It will take a few seconds. I'm sorry, I have not taken any break. Usually after 45 minutes, we need some break. I forget that. But I think I will finish it soon.
Excuse me, Aravind.
Yes.
Okay, after showing this project report, shall we have a break, and then shall we little bit discuss on that SETA article also?
Yeah, we can discuss that. I just wondering if anyone have any guys have any question up to
Yeah.
here.
Yes.
I just want to show them this report. Where it is. So this is the report. I think I will first share the screen. Yeah. So Homer has generated this report for us. So we can you see this report in the Word format? Whatever format we can choose, it will give us report in that form. You see, so here like the profile, electricity load profile, and the like the DG and the grid, how it is going to vary throughout the year. All parameter what we have discussed, we can get this report from that icon, and then we can analyze the results. You see here, but here like we have only load, grid, and DG, so it is not like very big report. But like if you have like PV battery, then you can analyze more. So this is basic of the report generation. We can analyze different years. So now, yes, up to this, if you have any question or any query, any clarification, we can discuss. Maybe then I will, as Konara mentioned, that I can discuss some more. I can give you some more overview of the paper that he has shared with you.
Aravind, shall we first have a break for 10 minutes or 15 minutes? And then we will have a discussion with the students if they have some problems related with the things that you have discussed so far. Mm-hmm. And after the discussion, we will come to the setup paper. Because in the setup paper, I think we have used photovoltaic plant as well.
Yeah.
Yes, because.
But yeah, but I think if they want me to develop this complete model for like what I developed for setup paper, I think first I would suggest they can try by themselves the features of the software, and then maybe if they feel any difficulty, then I can help them to develop this model, and then we can discuss. Maybe they can contact me if anyone they want. They can contact me, and I can help you developing this model. Yes, we can go like this. But yeah, the only thing is that I am like available till 4 o'clock. So maybe if you want a break, this is okay, or we can discuss this setup paper also. Then we can close. Either way, I'm okay. In 4 o'clock till 4 o'clock we can do today. Is it okay? We have 30 minutes. What everyone says. Is it okay to take a break if you have digested or overloaded too much?
Since there is no any objection to continue. Since there is no objection,
it goes both ways. If there is no objection, so
no, with my previous experience. Mm-hmm. So if they are tired, usually they request a break.
That's right.
What's your suggestion?
I forgot actually.
Can we continue?
Actually, it is only 15 minutes. I will just explain this. Then they can be free. 15 minutes. I will just explain the setup paper, but maybe next time I will stop in like 45 minutes. I was just with this software. I couldn't make this realize this time. Huh? Maybe I think I will continue for 10-15 minutes and will just explain the setup paper, and then we will stop for today.
Do you have any questions related with the things that he discussed so far? Are you all there?
Yes, sir.
So yeah, so I think I will just continue for like few for 5-10 minutes more. I will just explain you about the paper, and then maybe you can start developing this model, and I can help you if you need further help in developing this model, how it will be going to develop. But I will first explain what kind of analysis I have done in this paper, and that it will give you more insight into the work on the. So I am sharing a screen of the paper what Konara has shared with you before. So the paper title is can you see this screen? Performance assessment of institutional photovoltaic based energy system for operating as a microgrid. So you can see this paper, and in this paper there is a configuration of solar photovoltaic systems, battery bank, utility grid, and DG are connected here, and then loads are essential load and non-essential load. Okay, so this is the we can say the case one where the system is like this, and when we put the main capacity of all these components into the homework, then we are able to calculate the overall sizing of the systems in terms of what actual battery sizing required. So like in initial case, we don't have this like battery and PV. Okay, what I have discussed today. But when we put this basic information of DG, grid, essential, non-essential load, and we try to calculate the size of PV and battery, then Homer will give us the size of both. Okay, but in my paper, I have taken the PV capacity fixed of 50 kilowatt. Okay, and that capacity is being used as a like the we have the rooftop area available like where we can install up to 50 kilowatt. So that is being considered. And in this particular in this paper, the capacity is different. Okay, so you don't need to worry about that. The PV capacity is different because the paper the load data is also different, but the main concept is the same. Main concept is same. First, we have designed a system without like battery energy storage, and we are trying to find out the solution which where we can meet the load demand when grid is not available. So, like in initial case, DG is meeting the complete load demand when DG is meeting the load demand when grid is not available. But when we add the battery, so battery will reduce the grid contribution, and battery will participate, and solar energy will also used to enhance the overall performance of the system and reduce the grid contribution to the overall mixing or overall contribution to the load. So if I go in this paper like this, so this profile I have already shown essential and non-essential load, and then here you can see the how our battery is performing here. So in this analysis, what I did, I have taken like this battery performance graph. We can once we'll include a battery in the system. So what we can do, we can see how our battery is performing in terms of the solar, the battery charging status. Okay, in the battery charging status, you can see we can see how our status of battery is going to vary. throughout the period. Okay, and the minimum state of charge has considered 40%, and the battery charging is going to vary like from 100% to 40%. Okay, now in the next graph I have tried to show how our contribution from from PV, grid, and battery energy throughput are varying through in the different month of the year for meeting the load demand. So here green is representing the power from the grid, and red is presenting at the PV, and you see this blue is the average load throughout the different month of the year, and the yellow one is the battery energy throughput. Okay, we can see like PV has when PV is generating more power, PV is generating like in these two, like April, May, and here also October, November. So when our PV is generating more and more energy. So what we have concluded out of this, after sizing of the system, we have used this management strategy to enhance the overall performance of the system, and this is the energy management strategy which has been used here. This strategy will take time to explain how it works, but I think I would suggest you can just go through the energy strategy. The main objective of this energy strategy is to increase the PV contribution and reduce this contribution from the grid and the DG, and also to enhance the system performance in terms of reducing the overall economic cost, energy cost of the system. So here then what we did, this is the energy contribution of different sources from February month and then August month. So 2 months have been selected. So February is like the worst month, and the August is the best month in terms of PV production. So 2 months analysis has been done, and then again the battery performance. You see the August month results, and then how our battery is performing. Then battery results are also analyzed. You see, initially when we don't have any energy management strategy, that time how our system was behaving, and then later on in the upgraded system when we applied this energy management strategy, then our battery is going to perform. So you can see clearly difference of the different energy management, the energy role of energy management strategy to improve the battery performance. Yeah, the load profile I will yes, there is some query on the students. So I will give this load profile to, I will send this load profile to Konara. Maybe Konara will add this load profile to the canvas, and then you can develop the system. Okay, so there is no problem on that. Yes, I agree. We have not provided as of now the load profile. So now again, how we are going to analyze this results. So this is again month-wise contribution from PV, grid, and DG. And here you can see the black one is DG, and here the red is grid, and this green is, in this graph, is PV. So the overall, I have given the overall the overview of this paper. You can analyze the contribution from different energy sources and see how our performance of the grid is going to improve. Okay, so what I will do right now, I will just stop here, and I think I have given you just a brief overview of the system of Homer software, and you can start developing some program based on the load profile that we will provide, and consider the like different scenario based on this paper which is available in the canvas. And then if you feel any difficulty, then you can contact me. Okay, then maybe we can discuss further on this.
Excuse me, Aravind.
Yes.
Aravind, can you just explain that, not very, I mean, in detail, how to configure energy management strategy that you have shown using your flow chart?
Yeah, that's why I thought I would explain later on, because it will take some more time. I would prefer if they can first go through that. Yeah, the main objective of this, yes, I will explain. I will not take much time, but I still say that if they can first go through this, otherwise they will not able to understand it. But I will explain it how it is the energy management strategy is working here. In this block diagram, I think you are able to see the block diagram here.
No, I mean, just to show how to build this type of block diagram in Homer. So
no, in the Homer we directly cannot build, but based on the like once we work on the Homer and we see the how the system is taking our preference, based on our preference that we have selected, we have like we can create this like management strategy. Did you understand? Means Homer not in the Homer we can define the preference for the battery, preference for the grid, preference for our load when we have to give the priority to the load. But this is the overall like what is happening within the system in the Homer that I am going to show in the graphical form, in the illustration form, that how this battery is selecting what preference we have given. So like if I see here, and the first we are asking the Homer, they check the PV. So initially stage, the Homer is first giving priority to the PV. If PV is available, we can give more and more energy from the PV to meet the load demand. This is something that I have shown in the Homer software. Initially, we can choose an option that how our PV energy should be used. Shall it be used? Shall it be fed into the grid? Or shall it be used within to meet the load demand? Okay, then same time, in the same way, we can also see the operation of battery, how our battery should be performed, whether our battery should be used for grid outage only, or whether our battery should be used for meeting the peak load demand. So if I am concerned about the like high tariff price, so I can select that our battery should not be charged when grid tariffs are high. So we have option available in the Homer that when our battery should be charged, whenever battery should not be charged. So according to that, we will select that topology that our battery should not be charged when grid tariffs are high, and when grid is not available, then how our battery should be charged. So there is different option within the battery category that we can select, and then we can develop this like our strategy, how we are going to what kind of energy management strategy we are going to use in the system. So it can be vary, but based on this energy management strategy diagram what I have shown here. Here the main objective is the first priority to the PV, and then if PV and grid is not available, then the battery will take the second part, and grid is the lowest priority here. So in the same way, if you analyze the result in the result section of this Homer, so we will see the grid, the DG contribution is lowest, and also priority is the lowest. After once we are not able to find any energy sources within the system, then our grid, the DG will work. So that is the overall objective here. So this is the basic concept about the management strategy.
Yeah, it's clear. I think it's clear to the audience.
Yeah, still, if you have any one of you have any query, how we can implement and how we can draw it and how we can see the different battery configuration, different battery performance in terms of whenever battery should charge, whenever battery should not discharge, and it should be charged to a particular rate. And if I want to sell the electricity up to this rate, if I don't want to electricity up to this rate, we can do lot of combination and lot of combination permutation combination, and we can change our scenario. But in this particular case, the certain parameters have been fixed in order to the objective is to make the high maximum contribution from the local energy sources like PV, and make the battery more effective in order to meet the load demand and reduce the DG consumption. That is the main objective. So if our objective is something different, like if I am going to make a case for Norway where grid is quite reliable and grid electricity is always available, then our strategy would be different, because in that case I don't need to worry about DG, but I need to take care of the peak load pricing. Then our battery priority should be to take care of the peak load demand. So that time uh, we will not take energy from the grid, uh, but also we will try to feed energy from the battery, whatever we are storing into the battery when grid prices are low. So we can change this strategy here. So this is something that the very basic of this concept, but it's like lot of things, permutation and combination, we can play around it and we can analyze the results. So I think I should stop here, and Konara, I will share with you this load data.
Yeah.
Okay, and maybe you can put into the this Canvas system, and then anyone who need help. I think there one more question. In Homer, there are two controller types: Homer cycle and Homer load following. Apart from these, two can be implement another strategy. How can you implement? Is this logical diagram figure 7 implemented in that way under controller? If I think first of all you can go through a different control strategy which is available here. Maybe we can have a separate discussion on this if individual have a query on this, because this cycle charging in the Homer, we have a different kind of what we say, the dispatch strategy for battery available. So this is based on like one strategy, but if I analyze the result with a different strategy, then our result will be different. That we can compare these results. If we go in the Homer, I can show you, but not right now, the times will not permit me to do that. But in the Homer, we can compare the results of different dispatch strategy, and we can see which strategy are working in which scenario. But in that case, what will happen, the cost of energy generation would not be lowest as possible. But in this case, what I have shown here, the cost of energy generation, the main parameter. But if I choose like something else, energy management strategy, energy dispatch strategy here for battery, like instead of cycle charging or like uh, load following, there is also one load following, then it will be completely different. The scenario will be completely different. Our results will be also completely different. So we can compare also. There are a lot of analysis we can do in here. Like there are 4 different strategy in the Homer. We can compare results of all these 4 types of strategy with a different configuration of battery energy histories, and we can analyze the results how our system is behaving with a different scenario. This is also possible. Maybe I can discuss more into if individual want to pursue some more detailed project or more detailed analysis into a particular in a particular theme or particular topic, I would be very happy to discuss more about that.
Okay, shall we do like this? Now I will upload this load profile to the canvas,
Yeah.
and then you can try this setup paper. I mean, similar scenario, which is like this setup paper, and then you will be getting actual problems, practical problems. Then to discuss this problem, we will organize not just only to discuss the problems and just to show some other options like cycle charging and the load following and these things. We will organize another Homer workshop. What do you say, Arvind?
Yeah, yeah.
Is it good? Huh?
Yeah.
Yes,
Yeah.
because first, we should let them to practice by their own.
Yeah.
And then they will be getting actual problems. Okay. With that problems, we will continue this workshop. How about the, is it okay from the audience? If we go in that manner?
Yeah. Yeah, I just want to add here. I would request everyone to start to making some model based on I have just shared the load profile with you, Kunara.
Yeah, okay.
You can download it, and they
Yeah.
can you can first start work on the software this software, and then if you feel any difficulty, then we can discuss further on the different kind of strategy and how it works, how we can make our own strategy here that we can discuss further. This is very vast software. It looks very simple initially, but lot of analysis. You can make a lot of analysis here, a lot of analysis. So within a cycle charging, as I explained. So within cycle charging, a lot of things that we can do. So maybe it would be good if we give some time into the software, and then we can discuss more once you will go through the software and make some model and give some specific query where you are not able to analyze the results, and how you want to create some specific energy management strategy or energy dispatch strategy, battery performance or a particular scenario. Then it will be very nice to discuss further on that.
Yes, I agree with you.
Yeah, so I shared Kunara this load profile. I think you got it.
Yeah, I will upload it to the canvas.
Yeah, so maybe you students should not be worried that the load profile I have shared this time. This is I have used in the cleaner production paper. Okay, but the concept is same. You don't take this in a different way. The main concept is same. That you can choose the different load profile in terms of per kilo means per unit or kilowatt, whatever is given there. Okay, so in the setup paper, the load profile is different, and here the load profile is just up scaled up. It's scaled up for 50 kilowatt. So it doesn't matter. You can start making the model, and then it will be good. Okay, thank you so much everyone for your kind attention, and thank you Konara for making this lecture successful. And I hope you everyone have maybe got some good insight into the today's lecture. And still you have any problems, we will discuss in the maybe in the next session whenever it is going to organize. We will maybe Konara will let you know when we can organize the next session.
Yes, thank you also, Aravind, because of course I believe we had a very fruitful workshop today. And again, thank you accepting my invitation, very short invitation, and this workshop.
Thank you so much. Thank you so much. Okay, goodbye. Have a nice day.